Now that we've discussed how to add, subtract, and multiply complex numbers, let's talk about dividing complex numbers. And this will prove to be a little bit more challenging. Before I talk about dividing complex numbers, I want to introduce a useful definition that will help us in dividing complex numbers. That is the definition of the complex conjugate. So if you have a complex number, let's say 7 minus 2i, then the complex conjugate is obtained simply by taking the imaginary part and multiplying it by a negative. So in this example, the imaginary part of this complex number is negative 2i. So the complex conjugate which I will say CC of 7 minus 2i is 7 plus 2i. So we don't do anything to the real part, but on the imaginary part, we negate the imaginary part. So for example, the complex conjugate of negative 1 plus I is negative 1 minus I. The complex conjugate of I, or let's say perhaps 2I, is negative 2I. And the complex conjugate has this property that if you take a complex number, let's take our initial complex number 7 minus 2i, and you multiply 7 minus 2i by its complex conjugate, then the result will be real. Let's see why that is. So if I do this multiplication, the first term will be 49, the last term will be 14i, the inside term will be minus 14i, and then the last term will be 2 times negative 2 is negative 4i squared. And we see on the middle here, we have this 14i minus 14i, which will give us 0. This I squared will give us negative 1. And so negative 4 times negative 1 would be positive 4. So really what we have is 49 plus 4, which is 53. So this complex number times its complex conjugate gave us a real number. And this will happen every time. If you want to see why, you can just take a generic complex number, a plus bi, and multiply it by its complex conjugate, which is obtained by putting a negative instead of a positive. And what you get here is a squared, that's the first, plus abi minus abi minus b squared I. And abi minus abi will always be 0. And this I should be an I squared, because I times I is I squared. This I squared will be a negative 1. And the important thing here is that the imaginary components canceled, and we're only left with real numbers. So anytime you multiply a number, a complex number, by its complex conjugate, you're going to get a real number. This concept of complex conjugates will be helpful when we are dividing complex numbers. Now let's do an example of dividing complex numbers, and along the way we'll talk about the steps. So as an example, let's do the division 5i plus 1 divided by 2 minus 5i. Now, the first thing that we're going to do this division is we're going to multiply both the numerator and denominator by the complex conjugate of the denominator. Now first, remember, you can multiply the numerator and denominator by anything as long as it's the same thing, because when you multiply by the numerator and denominator by something where the numerator is the same as the denominator, really you're multiplying by 1 and you're not changing the complex number. However, the thing that is useful to multiply by in these examples is the complex conjugate of the denominator. So the denominator is 2 minus 5i, so I'm going to multiply by 2 plus 5i divided by 2 plus 5i. The reason why we do this is because now in the denominator, when we do this multiplication, we have a number times its complex conjugate. That will give us a real number. And in the numerator, we'll have a complex number, and that will simplify nicely, as we'll see. Specifically, by simplify nicely, we'll be able to write this as a number plus a number times I. Okay, so I'll go ahead and now multiply the numerators and multiply the denominator. So I got 5i plus 1, and I think I'm going to rewrite 5i plus 1 as 1 plus 5i. Just because that makes everything look a little bit more like the complex number arithmetic that I've been doing before. So in the denominator, we have 2 minus 5i times 2 plus 5i. And now you likely see why I might have made the comment that this is a bit more involved than the previous operations. We have here to do two multiplication problems, a multiplication problem in the numerator and a multiplication problem in the denominator. So in the numerator, we get 2 plus 5i plus 10i plus 25i squared. And in the denominator, remember, we should expect this to be real in the denominator. We get 4 minus 10i. Oh, that is the inside. I want to do the outside first, although to be quite honest, it doesn't matter if you do the inside or outside first. So plus 10i minus 10i, and then finally we get minus 25i squared. Now we can go ahead and simplify some things. So this 10i minus 10i, that will give us 0. And these I squareds are going to be -1. So I have 2 plus, I think I'll combine these two terms as well, 15i plus 25 times -1 divided by 4 minus 25 times -1. And so in the denominator, I'm going to have 29. And in the numerator, I'm going to have, as the real part, 2 minus 25, which will give me -23, plus 15i. Finally, we can go ahead and write this as -23 over 29 plus 15 over 29i, which is the standard thing to do, to write the real part first plus the imaginary part. So recapping, I think to summarize, we could say that the steps here is to first multiply by the complex conjugate. And when I say multiply, I should specify multiply numerator and denominator. By the complex conjugate. And then after that, there's a bunch of simplification to do. You have two multiplications, one in the numerator, one in the denominator. You have some simplifications of the I squareds, turning those into -1s, and combining the complex numbers that are in the numerator and the denominator.